This is R.D. Sharma Solution Class 12, Chapter 12, Higher Order Derivatives. Exercise is 12.1. If y is equal to 3 cos log x plus 4 sin log x, prove that x square, then we have the d2y by dx2, which we are calling as y2, and then we have the x y1 we are calling it as dy by dx, and plus y, which is the original thing. So before we go ahead, we have y2, y1 and y. So we have to find the differentiation first, then the double differentiation, and once you do this, you will see that finally this will come. Okay, so those who want to do by themselves, this is the solution for them as a reference, because most of the things are not being given here. If I tell you or some instructor will tell you, then only you will be able to understand. So let's go ahead, because there are certain things in exam how you have to write that has also contains many marks or weightage. So you need to know how to write also. Y is equal to 3 cos log x plus 4 sin log x here. Then we have to find out the y1, which is the differentiation of this. Y1 is nothing but the differentiation. We have dy by dx it is. So 3 cos log x. So it will be minus sin log x, and differentiation of log x is simply 1 by x in the denominator. Then we have plus 4 sin log x. So it will be cos log x, and differentiation of log x will be 1 by x. So what do we get? See, this whole we just add minus 3 sin log x, and this we have plus 4 cos log x, and then we have x in the denominator. Why we have done this? Because this will be easier when we want to find out whether it is y1 or y, and because the equation we have to fulfill, so we have to do the y2, which is d2y by dx2, double differentiation, that is. So y2 will be equal to, we have, this is say p, this is say q, so p by q we have to do. So let us use the quotient rule to solve it. We have x here, so it will be x square. Here we write x, and the differentiation of this upper content. So minus 3 sin log x will be cos log x, and you know this, and differentiation of log x is 1 by x. Here we have, since I am having a view that this cos log x will give you minus, so I have written minus already. We have 4 sin log x, and then differentiation of log x is 1 by x. This x outside can be multiplied inside, so that we get rid of the denominator x in the numerator. That is, I am multiplying x inside. This is just one part. Okay, now second part is, just assume that x square is in the denominator. So we write this content, because we are following the quotient rule. So minus 3 sin log x plus 4 cos log x. Differentiation of x will be 1 only, and as I said, because of the lack of the space, this is x square in the denominator already. So this we already have, because y and y1 we have already computed. So I am taking negative outside for the first term. When we multiplied x, 1 by x and 1 by x already disappeared, and then we have this minus 3 cos log x minus 4 cos log x, and if you take negative also out of it, then what do you get? 3 cos log x, and then we have cos, I am writing in short so that we utilize the space. Then we have minus 4 sin log x. So this x square is in the denominator for all of it. Then this is negative. What content we have here? We have minus 3 sin log x plus 4 cos log x. They are same term. Okay, the numerator is same, so we have just divided them 2 to make it easier. So we have minus 3 log, same thing is there is no differentiation as such. So now this negative can be taken out. This is 3 log cos x plus 4 sin log x. So if I just place negative here, it will be negative y. So the numerator is nothing but negative y, and then we have x square in the denominator. This is what? Minus 3. This is minus 3. Just see the y1. It is minus 3 sin log x plus 4 cos log x. If I write this x in the denominator, x square as x into x, this whole term is nothing but, already we have found the y1, so you can just write y1 here. This is your y1 divided by x. So this x square we have already used. 1x used, and was x is in the denominator. So we have started with d2y by dx2. So this is y2. What you will do now? Just multiply whole by x square. And once you multiply it by x square will be here, x square will be here, x square will be here. This becomes x square into y2, and this gets cancelled. Minus y goes on the left with plus y. Here also x will remain, it goes on left, it will be plus x y1 equals 0. These two equations are similar, exactly similar. Yes, so this is how we go about it. There's a lot of replacements here. Next is y is equal to e raised to x ax plus b. We have to show y2 minus 4y1 plus 4y is equal to 0. y2 is d2y by dx2, y1 is dy by dx. So y is equal to e raised to x ax plus b. Then y1 will be equal to, we will do it using the product rule, e raised to x. Ax plus b differentiation is what? B is 0 and ax, so only x a will remain. Differentiation of x is 1 only. So e raised to x into a plus ax plus b, and then we have here ax plus 2b, and differentiation of ax e to the power 2x is 2x only, and then 2 comes. So how can we write this? A e to the power 2x plus 2 e to the power 2x ax plus b. This is y1. This is dy by dx. So let us go about finding the y2. Then we'll come later to what kind of equation do we want, which is required in this example. So y2, we have a e to the power 2x differentiation. A is constant, so differentiation of 2x is 2. So we have 2a e to the power 2x as the first term. Coming to the second term, as I said, we already have a 2 here. E raised x to x ax plus b is already been done. This is nothing but y. This is y only. And differentiation of y, that is y1, is already being done. So just take y1 and keep it here, or place it here. A e raised to x plus 2 e raised to x ax plus b. So just multiply 2a e raised to x plus 2 to the 4 e raised to x ax plus b. 2a e raised to x, 2a e raised to x, this is 4a e raised to x. Then we have 4 e raised to x ax plus b. This is y2. So what all we have, what all we can do here? So I can write this, we already have a y2 and we have this 4y also. Now how this y has come? See, y is e raised to x plus ax plus b. So I have written 4y. What are we getting here? Are we getting something out of it? If not, then we'll apply some other tactic. y2 is 4y is also there, y2 is also there. So what is minus 4y? y1. Now let us go to y1. This y1, if you see this one, ax plus b plus e raised to x is what? This is y only. So y1 can be written as a e to the power 2x plus 2y. This equation I'm talking about, because I'm not getting to the solution. I'm not getting the solution. So I went again to y1, and y1 I found it to be a e raised to x, and this whole was y only. So I can just write 2y. That is a raised e to the power 2x can always be written as y1 minus 2y. So this is a raised e to x. What do we have here? 4 into a into e raised to x, that is 4 into whatever is on the left hand side from this equation we got. So it will be 4 y1 minus 8y. So y2 will be equal to 4y1, we already have it, and minus 8y plus 4y is minus 4y. So 4y1 minus 4y we got. Now take everything on the left, So we have y2 minus 4y1 minus 4y equals 0. This is your final equation. So see, the solution which I provided you is different, and the solution which I did is different. That is why there can be multiple ways which we can go about it. It totally depends on your practice. Next one is x equal sine 1 by a log y. So this can be easily converted into a way which we already done. So because differentiation of this will be a task, quite a task. So x equals sine 1 by a log y. Sine I am taking here. It will be sine inverse x equals 1 by a log y. This a, let us multiply both sides by a. So we have a sine inverse x equals log y. Now we already know log. If I say log a equals b, the base is e. So it is nothing but a way of writing e raised b equals a. E to the power b is equal to a. This a sine inverse x equals y. Same logic I have applied here. So when you have y equals e raised a sine inverse x, now we have already done a question like this, okay, and this you know how to get this. If you go to question number 20, 21 and the question before that, this kind of question is already been done, okay. So this is how you can go about, but this is y. So first you have to find out y using all the rules you have in your pocket after learning mathematics. Then y1, the differentiation of e to the power anything will be that thing only. So e to the power a sine inverse x, then the differentiation of a sine inverse x has to be done. So we have a, differentiation of sine inverse x is 1 by under root 1 minus x square. So what is this? Y equals e a sine inverse x. So this is what? This is nothing but y. So y1 is equal to ay divided by under root 1 minus x square. y1 is equal to ay by under root 1 minus x square. Okay. Now what we'll do here is, a will use it later. Just keep it aside. We have y by under root 1 minus x square. What you can do is, you can either apply the quotient rule or a product rule. It's up to you. So if you multiply this on the left hand side, y1 into under root 1 minus x square, you won't get anything. So let us differentiate it. So I'll apply the product rule here. First will be y. Differentiation of 1 by under root 1 minus x square is what? We've already seen that. So you can call it as 1 minus x square to the power minus half it goes into the numerator. It will be minus half 1 minus x square to the power of minus 1 minus half minus 1, that is minus 3 by 2. Differentiation of 1 minus x square is minus 2x. 2 gets cancelled, negative gets cancelled. So you have x. So 1 minus x square to the power 3 by 2. This is nothing but 1 minus x into under root 1 minus x square. Why? Because 1 minus x square under root is half only. Half plus 1 is 3 by 2. So finally we got 1 minus x square under root 1 minus x square. There is a x also, and there is a also. Please remember x and a. Now 1 by under root 1 minus x square, and then what do we have? See, differentiation of y is what? Dy by dx. Okay, so we are different. If you say dy by dx, you have to write just y1. So y1. So ay, x was also there, as I said. Now ay by under root and 1 minus x square is nothing but y1 only. So y2 is equal to y1, this whole y1, this y1 by 1 minus x square, y1 by 1 minus x square. Here you have this a y1 by under root 1 minus x square. So how to get this? So how can we get this? Okay, when we did that, this, if you remember, I told you x was already there. So don't forget about x, writing it as x. Here you have, so is this one. Let us introduce this again. Ay by under root 1 minus x square. So we have ay, I'm writing ay by under root 1 minus x square, under root 1 minus x square. In place of y1 I am replacing ay by under root 1 minus x square. What do you get? A square y by under root get cancelled, you get 1 minus x square. Here we have x y1 by 1 minus x. So you have 1 minus x square multiplied on the left hand side, or all members you can multiply by 1 minus x square. So you have left in this x y1, and then we have plus a square y. Now bring everything on the left hand side. So you have 1 minus x square into y2 minus x y1 minus a square y equals 0. This is your final equation. So there are two replacement of y.